Hello people of 2018, I'm William Thompson and I'm one of the scientists who contributed to the thermodynamics laws, and I'm going to teach y'all about them. So over here we have the zeroth law, which basically states that if the energy in one system, for example A, goes to the another system B, and then B goes to C, then A would equal C. So heat's not lost. The next law is the first law, which is the law of conservation. So basically the change in kinetic energy is equal to the heat plus the work. Next is personally my favorite law, which is the second law of entropy.
Entropy is basically randomness or disorder. Three ways to increase entropy is spread out, heat up, mix up. Entropy!
And basically, entropy is just randomness. It's always going to be increasing, it never decreases. So,
Albert N. Lewis, an American physical chemist, best known for contributing to chemical thermodynamics and electron pair model of the covalent bond. And I will be teaching you about the ideal gas law, also known as equation of state. The ideal gas law was actually formed by a few scientists and mathematicians, especially Robert Boyle, Jacques Charles, and Joseph Luzak, which I'll be talking about later on. And the ideal gas law is P, which is pressure measured in Pascal, times volume, which is measured in meters cubed, equals N, which is number of moles, times R, which is the gas constant, which is 8.3 times joules divided by moles times Kelvin, and T, which is temperature measured in Kelvin. And thermodynamics is a flow or heat transfer of heat energy, also known as thermal energy. Heat will transfer from high temperature to low temperature, and heat will continue to transfer until thermal equilibrium is reached. Now I will show you three ways heat is transferred. First one is conduction, which is also known as touching. And I will take this metal rod and I will poke the fire, and the heat will transfer from the end point of this metal rod into the handle part, and heat will continue to transfer until the temperature of the metal is equal to the temperature of this fire. Second is convection, which is heat transferred through molecular motion in a form of liquid or a gas state. For example, this as water is being heated, warm water becomes more buoyant and it rises up, while the cold water becomes more dense and it descends down on the bottom of the pot, which creates a pattern of circulation known as convection. Third is radiation, which is heat being radiated or transmitted through the form of electromagnetic waves. For example, the fire of this stove radiates heat, which boils the pot over here. Hello, I'm Jacques Charles, and I'm an inventor, scientist, and a mathematician who discovered that if pressure is constant, then volume is proportional to temperature. That would make volume 1 divided by temperature 1 equals volume 2 divided by temperature 2. Next, I will be introducing Robert Boyle, who is a physicist, chemist, and an inventor who discovered that if temperature is constant, then pressure is proportional to 1 over volume, which would make pressure 1 times volume 1 equals pressure 2 times volume 2. Another contributor to thermodynamics is Joseph Gay Luzak, who discovered that if volume is constant, then pressure is proportional to temperature. That would make pressure 1 divided by temperature 1 equals pressure 2 divided by temperature 2.